Namaste everyone. Today we are about to learn the concepts of a chapter whose applications are observed not only in our daily lives every day but also at various points in different industrial methods. Yes, I'm talking about methods of separation. So we can see the methods of separation in all walks of life, be it drying of wet clothes using a dryer or separation of rotten vegetables from the fresh ones, be it during the recycling of several materials including clothes, paper, glass, plastic, ceramic, or if it is to obtain pure substance like obtaining sand from a mixture of sand and pebbles. Here you can see this particular gentleman, he is going through this slurry in a river where he is hand picking the nuggets of gold which are there in this slurry. So as you can understand, this slurry consists of pebbles, stones, sand, and so on. Among them he is hand picking this stuff which is of more economic value. Whatever method we use to separate a particular item, we have to ensure that the method should be cheap, it should not cause much harm to the environment, it should not cause much delay to our process, and it should also be very much viable from every person's point of view. That means if the process is typical to a rural economy, every person in the rural economy household should have the know-how to pursue it. I will cite an example that this hand picking, here the contents, as you can see, pulses and oil seeds are being separated using this hand picking, and of course there are several pebbles which are being rejected, right? In the similar scenario, this grains of different color, red color and yellow color, they are being separated by using this hand picking. So there should be sufficient know-how among the populace who are using it to pursue that particular method. Similarly, there is this particular method called thrashing. So nowadays we have this mechanical thrasher, but in earlier days what used to happen, whenever we used to grow crops like paddy or wheat, so the grains used to be separated from the straw using this by beating the straw against a hard substance like a stone or a wood, so the grain would be separated. And in the similar line we have winnowing. Winnowing is it the method of winnowing uses the difference in densities of two substances which are mixed together. Here the husk and the grains have been mixed together, so using the force of the wind, the husk and the grains are separated. The husk which is of less density, which are lighter, those are blown away, and the grains which are of higher density, they fall down towards the ground, they accumulate here and then they are removed for further use. There is another method, it is used in our common day life, which is sieving. So sieving can be used to separate solids. Always remember, solids, not solid and liquid. Solids which are of different sizes. So when I say different sizes, as you can understand that you cannot use this method to separate sugar and salt because both are of same sizes. But in the case of sand and pebble, sand and gravel, as they are of different sizes, so this mesh is used to separate this objects of different sizes. So the object with the higher size will get entangled by this mesh, and the object of finer size, smaller size, will pass through. If we have n number of substances, many substances mixed together, then we can use this multiple sieves, this multiple meshes, so that we can accumulate substances of different sizes. Then this can be removed individually for use. So please do remember that this cannot be used for solid and liquid. This cannot be used for solids of similar sizes. Some more examples include, we want to remove some suji, say semolina, from rice, or we want to remove the sand from gravel. If you go to some construction site, you will see that they remove the sand from gravel, and so that the sand can be mixed with cement to produce concrete. Okay. You can see in our everyday life, suppose we are preparing coffee or tea. So after preparation of tea, we use this filtration method. Okay, we use a sieve here, so that the solid residue is deposited in the equipment here, and the liquid, that is tea, is filtered out. So this method can be used or is used in our everyday lives. Let's suppose in case of water, so the strata of earth, which consists of sand, coarse sand, pebbles, bricks, stones, and so on, that is used every day, day in and day out, to filter water, which is later used by us for drinking, bathing, for irrigation, and so on. There is further use of sedimentation and decantation. If you may have seen that if there is a mixture of two immiscible substances, two or more immiscible substances, they can be, if they are left for to stay for certain time. So say you are washing rice, and you leave the mixture out for some time, so the water will be on the top, and the rice will deposit on the bottom. So both these substances have to be of different density. In case of oil and water, as you can see, the oil is lighter, it is of lesser density, so it deposits in the top, and the water deposits in the bottom. So you can remove this oil from water using a process called decantation. Similarly, two or more immiscible substances, here you can see the solid, it has deposited at the bottom, and the water, it is remaining, that can be further removed to a different, poured out to a different container using this process of decantation. There is one more method. We do not see it usually, but it helps us a lot in industrial sites, called magnetic separation. So as you know, there are certain substances like nickel, cobalt, iron, etc. So these substances, they are magnetic in nature. These substances, when they are mixed with some other non-magnetic substance like sand, gravel, pebble, etc., so they can be removed using this magnet. Here you can see in the large sites, large industrial sites, where a lot of waste is accumulated together. So the iron, which is of higher economic value, that is separated using this magnetic crane, that or rather electromagnetic crane, and from the rest of the garbage, and this iron can be later be used for other purposes. One of the very good examples which we say every day is evaporation. So evaporation is that when liquid substance is converted into a gaseous substance using heat. So the process is known as evaporation. So what happens, that the molecules of liquid, they get energy, and they get separated. The distance among them increase, and they get separated. So energy or heat, they get separated, and they convert into gaseous substance. So water gets converted into water vapor, and subsequently, say this cloth, if it is wet after getting sufficient heat, it will get dry. But there is not just heat, there are several factors which actually affect this evaporation, such as wind velocity. You will see if it is a windy day, okay, if there is the wind velocity is more, so these clothes will get dry faster. Similarly, surface area. If this cloth, the same cloth has been exposed to sun in a crumpled manner, instead of fully expanding it, if it is crumpled down and then it is hanged out to dry, it will take more amount of time to get dry. So if the surface area is more, if it is exposed more, so it will dry faster. If the wind velocity is more, it will dry faster. Why? So we had discussed in last lecture that there is a certain carrying capacity of air molecules. When it's a windy day, the air molecules, if the humidity is less, humidity means the water content of the air molecule is less, so the carrying capacity is more. So the wind or the air can carry more water molecules, more water vapor molecules from this cloth, and the cloth will dry faster. But if it is humidity is more, or if it is not a windy day, so that means the number of water vapor molecules or water molecules in this air is more, the carrying capacity of air is less, so it will not be able to dry the substance which has been left out to hang, or the clothes which have been left out to hang, much faster. Similarly, you can see this salt pans. This water, seawater, is left here in this salt pans. It has been exposed to sun by maximizing their surface area. Okay, if this surface area is less, say instead of this flat pan, if this is designed like this, okay, or like this, so the rate of evaporation will be less. Okay, so instead it has been exposed to sun like this by maximizing the surface area, so that the water can evaporate faster and the salt can be collected for further use. We have come across a word called sublimation. It's a process where a solid substance directly converts into a gaseous substance. There is no immediate intermediate liquid phase. So after you can see this mixture is heated, the temperature rises. Say this is a mixture of sand and camphor. The camphor will sublimate and it will convert to vapors. But here we have used a wet cloth which will reduce the temperature. Okay, which will reduce the temperature. As a result, the sublimate or the vapors will condense down and deposit here on the walls. You can see here in a mixture of ammonium chloride and salt. Ammonium chloride is a substance which can undergo sublimation. After application of heat, it evaporates and later it deposits down, where after being cooled down, and later we can collect these two substances individually and make it to some use. We have this very important process called distillation, where two or more liquids, remember that two or more liquids or solid and several liquids, they can be separated using this process of distillation. What happens is, when we heat a substance, it is a similar phenomenon, that the substance will or the liquid will evaporate and it will go through this particular channel. Here we are using this condenser. That means the temperature of this vapor is being reduced. This is cold water. As you can see, always remember that the cold water will go in from the bottom and come out from the top, not the other way around. It will never go from the top and come out from the bottom, because then this time spent in this area will be minimum in that case, and it will not be able to cool the vapor sufficiently. So this will always be from bottom to top. So this cold water reduces the temperature of this vapor and it condensates into liquid. and the remaining liquid which was mixed with the previous one, say called liquid number 1 and liquid number 2, this can be collected from here. So many substances like perfume, alcohol, these are prepared using this method of distillation. And when we have certain mixture like petroleum, in petroleum it is a mixture of several substances like petrol, diesel, several kinds of gases, methane, ethane, naphtha, kerosene, and so on. So the boiling point of these substances are very close. The boiling points are very close, so we cannot use this apparatus, this simple distillation, to separate those liquids. So what we use this complex apparatus. Okay, this complex apparatus is used for separating those substances. As you can see, we in the beginning we heat the mixture to a considerable amount so that all the substances which have been mixed will get converted to gaseous phase. Subsequently, the temperature of this mixture has been reduced as it goes to top. As it evaporates to top, the temperature is reduced. So whenever a particular substance reaches its condensation point, which is same as boiling point, it condensates down and is isolated. This is a very really important concept. Okay, so whenever the temperature is reduced and after say being heated to 500 degrees Celsius, this fuel oil, okay, it reaches 350, it condensates and it can be isolated. But the diesel oil whose condensation point is 250 will still remain in gas and it will not condensate here, rather it will condensate here, it will convert to liquid and it can be isolated, and so on it will go.
So that would be all for today. Hope to see you in the next lecture.